Imagine if you had, so we're going to talk about calibration. Imagine if you had a series of samples. We're going to talk about for temperature measurement. And each one of these samples was at a known temperature. Let's say this one is at 20 degrees C, 25 degrees C, right? 30 degrees C, 35 degrees C. How do you know that? Perhaps you have used your gold standard, but you have true knowledge of the actual thing. Great. You come along with the device, right, that you've made. This is your device. Here's your display. And I'm going to be specific here. The display here is your voltmeter, right? So the output of your device remains at this point at the voltmeter stage, right? This is your piece of equipment. Obviously, this is your sensor. Here's your circuit. We know this very well, all right? Generate a plot that looks like this. Here's the actual temperature. We have 20 degrees C, 20, 25, 30, 35. And this is your measured voltage. Right? The actual voltage that you measured out of it. Let's call this, right, 1 volt, 2 volts, and so on. You measure value here, meaning when you took your device into here, you measured 1 volt. When you put your sensor in here, you measure 2 volts. When you put your sensor in here, you measure 3 volts. And when you put your sensor in here, right, to be clear, this was 4 volts, 3 volts, 2 volts, and 1 volt. These were measured points. This is, in essence, a calibration. Now, you come to a new sample, and you don't know what the temperature is. Right? You don't know what the temperature is. So you dip your device inside and you measure 2 volts. Right? 2 volts, right? Now, what is the normal process that you would do at this point? That's here. Okay, what's your thing? What's your thing? Write the equation, put the 2, right? Okay, 2 volts. So we do the solving and we calculate the temperature and we do that, right? That would be the normal procedure. However, as I've laid it out here, I haven't even told you what the circuit is, right? You measure 2 volts. What's the temperature? Not a trick question, right? What's the temperature? 25 degrees. You just know it. We repeat it and you measure 4 volts. What's the temperature? 35 degrees, right? You repeat it again with another sample. Now this time you measure 3.5 volts. Well, that you didn't get before, right? You don't have a 3.5 volts. But I've made the example pretty intuitive here, where you can say, well, what I'm going to do is I'm going to draw a line through these points or fit them. Seems like it. Seems like there's a linear relationship here, or another relationship, right? And what I'm simply going to do at this point is, once I have this line, for any voltage, I can see what the associated temperature is. I'm not relying on an equation in this case, right? This is one use of a calibration, right? I'm simply relying on, I've calibrated the device using the gold standards, and that's what I'm going to rely on. Here's the question. You've done this, and you've done that. It is absolutely critical that you report the correct temperature. When you do this, and you get 3.5 volts, you, based on the calibration, conclude that the temperature is 32.5 degrees C, right? It's right there, right? In fact, you've done averaging. You put it back in, 3.5 volts. Take it out, put it back in, wow, it is 3.5 volts. And that corresponds to 32.5. Okay? But you have a lab partner who always thinks they know better. They say, no, 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 not that. Let's go here. Plug in the equations, right? Take the voltage, calculate the temperature, and all the way on this end, on the other end of the board, they calculate, notice I'm using the word calculate, a temperature of 35.6 degrees C. And they've checked their math. Is your math right? Yeah, wait, are you sure? Yes, the math is right. You have one chance to report a value, right? And your performance will be based on that. What would you do, right, if this happened to you? And this will happen to you. I 100% guarantee that this is exactly what's going to happen. This is which number would you report? What's that? You do 32. Raise your hand if you do 32.5. You can raise your hand for either. And raise your hand if you would do 35.6.
Is this a trap?
It's not a trap. This will happen. No matter how sophisticated the device you work on is, this will happen. And so what we're going to discuss is, you're going to have to make your own decision, right, as you move, for each project. As we go through the course, we will address this issue. I mean, one thing you might do is you might go and start going through these issues. Say, wait, I'm not comfortable with it. I'm neither. Swap the components, address noise, change the components, right? That's one thing you could do. You can say, I'm not comfortable with any of these situations, right? And I'm going to use this opportunity to try to kind of get things better, right? So in that case, you are not using the calibration as an end in itself, right? You were actually using the calibration in the sense of, right, if the calculation does not match, right, we need to do something, right? So 2 uses of calibration, and there'll be additional ones as well, right? And there'll be additional ones as well. So that's your introduction to calibration as one tool we use in making our instruments work better.